Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let's have part 2 of our lesson, Random Variables. Now, for our activity, let's have experiment number 1, tossing a coin 3 times. So let us toss a coin 3 times and use capital H for the heads and capital letter T for the tails. Now, the question is, how many heads appeared when we toss the 1 peso coin 3 times? Now, consider this illustration. If we toss a coin once, the possible outcomes are head and tail. For the second toss, it can be head, tail, and also head, tail. For a third toss, possible outcomes are head, tail, head, tail, head, tail, and head, tail. So therefore, the outcomes are head, 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 or H, H, H. Next, head, head, tail, or H, H, T. Next, head, tail, head, or the H, T, H. Next is head, tail, tail, or the H, T, T. Next is tail, head, head, and that is T, H, H. Next is tail, head, tail, that is T, H, T. Next is tail, tail, head, that is T, T, H. And last, we have tail, 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 that is T, T, T. And these are the possible outcomes in tossing a coin 3 times. Now, let the random variable capital letter X be the number of heads. So, if our random variable capital X is the number of heads, in this instance, there might be 0 head in this outcome because the 3 tails appears. And there might be 1 head appear here, another here, and here. And there might be 2 heads appear in these outcomes. And here, and here. And of course, there might be 3 heads that appear. Okay? Thus, the sample space is equal to 0, 1, 2, and 3. Meaning, the results or outcomes are not entirely equally likely. The 3 coins could land in 8 possible ways. And that is 1, 2, 3, 4, 5, 6, 7, 8. And that is the possible landing of tossing a coin 3 times. So, the probability of the random variable X equal to 3 is 1 over 8, meaning 1 case of 3 head. And the probability of the random variable X equal to 2 is 3 over 8. That is 3 cases of 2 heads. And the probability of X equal to 1 is also equal to 3 over 8. And that is 3 cases of 1 heads. And the probability of the random variable equal to 0, meaning no heads that appear, is 1 over 8. That is 1 case of 0 heads. So, if we are going to determine the summation of the probability of the random variable X, that is now equivalent to the probability of the random variable X equal to 0 plus the probability of the random variable x equal to 1 plus the probability of the random variable x equal to 2 plus the probability of the random variable x equal to 3 is 1/8 plus 3/8 plus 3/8 plus 1/8, which is equal to 1. And this concludes properties of a discrete probability distribution, or a DPD. Property A: the probability of each value of a discrete random variable is between 0 and 1 inclusive. In symbol, probability of the random variable x is greater than or equal to 0 but less than or equal to 1. Second property: the sum of all the probabilities is 1. In symbol, sigma p of x is equal to 1, meaning the summation of the probability of the random variable x is always equal to 1. By inspection, the probability of the random variable x is equal to 3 is 1/8, and 1/8 is between 0 and 1, which is correct. Likewise, for 3/8, that is also between 0 and 1. Another 3/8, whose probability of the random variable is equal to 1, is also between 0 and 1. And also 1/8, whose probability of x equal to 0 is also between 0 and 1. Therefore, property 1 satisfies this data. And for our solution B, property B, or property number 2, satisfies our conclusion or solution, meaning the summation of all the probabilities of the random variable x, wherein x is equal to the number of heads, is always equal to 1. That is 1 plus 3 is 4 plus 3 is 7 plus 1 is 8/8. That is now equal to 1. Property B, or 2, satisfies the definition. Okay, let's have example number 2. Take a look at the table on the right. Let x be our random variable and assume to be equal to 0, 1, 2, and 3. And p of x be the probability of the random variable. The probability of 0 is 0.2. The probability of 1 that appear is 0.3. The probability of 2 is 0.3. And the probability of 3 is 0.2. Now, take note that the probability of x is satisfies by property A, wherein 0.2 is between 0 and 1, 0.3 also is between 0 and 1, 0.3 is also between 0 and 1, and 0.2 is also between 0 and 1, meaning property letter A of the discrete probability distribution satisfies. And if we are going to determine the summation of the probability, that is now 0.2 plus 0.3 plus 0.3 plus 0.2 is also equal to 1, which satisfies the second property of a DPD, or discrete probability distribution. Next, let's have example number 3. A spinner is divided into 4 equal sections. Let capital X be the score where the arrow will stop, numbered as 1, 2, 3, and 4 in the drawing below. Question A. Find the probability that the arrow will stop at 1, 2, 3, and 4. Question B. Construct the discrete probability distribution of the random variable x. Now, for our solution, this is our spinner, numbered 1, 2, 3, and 4. So let capital X be the random variable which is the score on the spinner. Meaning, our random variable X are 1, 2, 3, and 4. So, the probability that the arrow will stop at any of the 4 sections is 1 out of 4 or 1/4. So, the probability that 1 will stop is 1/4, that 2 will stop is also 1/4, that 3 will stop is also 1/4, and 4 that will stop is also 1/4. So, take note, these are all between 0 and 1, meaning 1/4 or 0.25 is between 0 and 1, which satisfies property. If we plot the result on a table, the random variable X be equal to 1, 2, 3, and 4, and the probability of the random variable X is 1/4, 1/4, 1/4, and 1/4. So by property 1, the probability of the random variable X is between 0 and 1 inclusive. And for property 2, the summation of the probability of X is equal to the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 equal now to 1/4 plus 1/4 plus 1/4, which is equal to 1. And that satisfies property 2 of the discrete probability distribution. So, to conclude, both properties are satisfied. Therefore, the distribution is a discrete probability distribution or a DPD. Sample number 4. Shown below is the discrete probability distribution of the random variable capital letter X. Determine the value of the probability of 2 and construct a probability histogram for it. Okay, given the table whose random variables are 0, 1, 2, 3, and 4, and probability of the random variable is equal to 0.1, 0.2, this is the question, unknown, the required one, and 0.2 and 0.2. So for our solution, let us use property number 2 to find the value of the probability of 2. So we have summation of P of X is equal to the probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 and plus probability of 4. Since the summation of P of X is always equal to 1, then 1 now is equal to the probability of 0 is 0.1, the probability of 1 is 0.2, plus the probability of 2, which is unknown, so just bring down P of 2, plus the probability of 3, which is 0.2, and plus the probability of 4, which is 0.2. So adding this, that is now equivalent to 1 equal to 0.7 plus P of 2. And then, to solve for P of 2, just simply transpose or subtract 1 to 0.7, and that is now 0.3. So therefore, P of 2 is 0.3. Now, let's construct the probability histogram for example number 4. So as shown, just simply, if the random variable is 0, the probability is 0.1. If the random variable is 1, the probability is 0.2. If the random variable is 2, the probability is 0.3. If the random variable is 3, the probability is 0.2. And if the random variable is 4, the probability is 0.2. So just simply draw or sketch the graph using the probability histogram. That's the histogram of the example given. Thank you for watching. See you on my next video. Bye.